In the past 4 days, 5 fireballs have streaked across the eastern half of America. One of them a 5.5-ton stony meteoroid that broke apart 31 miles above Cape Cod Bay. And then, this morning, in a span of 10 hours, the sun fired 3 times, an M9.3 flare at 1:36 Universal Time, an M7.7 at 7 o'clock, an X1.0 at 11:28, all from the same sunspot, a magnetically reversed wrong-way region that breaks a rule George Ellery Hale wrote down in 1919. 2 confirmed Earth-directed coronal mass ejections are already on their way. A third is inbound. A slower eruption from yesterday is between us, and the faster eruptions behind it, and NOAA's own discussion text says the interaction is highly likely. The published forecast says quiet. The discussion text behind the forecast says modelling is still ongoing. If you've been watching the sky over America for the past 4 days, subscribe to the Sky Lab because what is happening above us this week is exactly the kind of story this channel was built for. Drop a comment with where you are watching from and whether you saw any of the fireballs over the past 4 days. Share this video to help us grow this community. Now, let's get into it. Part 1. The 10 hours. At 1:36 in the morning Universal Time on Wednesday the 3rd of June 2026, the surface of the Sun did something that the public forecast had not anticipated. A region on the visible disk numbered 4455 erupted in an M9.3 flare. That class of flare is just below the threshold that NOAA labels X-class, which is the highest category in the standard solar flare scale. It was bright enough to register an R2 moderate radio blackout across the sunlit side of Earth. It was accompanied by a sweeping wave of radio noise called a Type 4 burst, and by a separate 10.7 centimeter radio burst that peaked at 360 solar flux units. And, most importantly, it launched a structure that became visible in the LASCO C2 coronagraph at about 2:13 UTC, a faint but identifiable cloud of solar plasma moving outward into the inner heliosphere. The Space Weather Prediction Center, which is the operational forecast office of the National Oceanic and Atmospheric Administration, took one look at that cloud, ran it through triangulation with the Stereo A spacecraft on the other side of the Sun, and confirmed what almost no morning forecast wants to confirm. There was an Earth-directed component. The cloud was coming this way. That was the first flare. 5.5 hours later, at 700 UTC, the same sunspot region fired again. This was an M7.7, a class also called Type 2b in the older optical classification scheme, which is essentially the largest, brightest class below X. It also registered as an R2 moderate blackout. Its 10.7 centimeter radio burst peaked at 540 solar flux units, which is the highest of the 3 bursts that would happen that day, and which is a number that solar physicists pay attention to because it indicates an exceptionally efficient coupling between the flare's particle acceleration and its radio emission. It also produced a separate signature called a Type 2 radio burst with an estimated shock velocity of 313 km per second. That shock signature is what radio astronomers see when an eruption is moving fast enough to drive a magneto-hydrodynamic wave through the surrounding coronal plasma. Translated out of the jargon, it means the eruption was strong enough to push the solar atmosphere out of its way as it left. The CME from this second flare became visible in the LASCO C2 coronagraph at about 7:48 UTC. The Space Weather Prediction Center noted in its discussion text that the bulk of this eruption appeared to be deflected northward by a nearby coronal hole, which is a kind of structure on the Sun where the magnetic field opens outward and acts almost like a guide rail for whatever comes near it. But the discussion also said something else, in plain language, that the audience watching this video deserves to read for themselves. The triangulation with Stereo A also indicates this CME has an Earth-directed component, so even though part of it was nudged out of the way by the coronal hole, part of it is still coming our direction. Modelling, the discussion text added, is still ongoing. Then, 4 hours later, at 11:28 UTC, the same sunspot region did it a third time. This was the big one. The X1.0, an R3 strong radio blackout, the highest classification of the day, the kind of event that interrupts high-frequency radio communication across the entire sunlit hemisphere of Earth for nearly an hour. The 10.7 centimetre burst was actually lower than the two flares before it, peaking at 250 solar flux units, which on its own is interesting because the X-class designation comes from the X-ray output, not the radio output, and the relationship between the two is not one-to-one. If a CME is associated with this third event, the Space Weather Prediction Center said, it should become visible in the coronagraph imagery within a few hours of the morning briefing. At the time this video was put into production, the third eruption was still inbound to the coronagraph field of view, still being characterized, still being modeled. 3 major flares from one sunspot region in 10 hours. 2 confirmed Earth-directed coronal mass ejections already on their way to us. A third inbound. And, as you will hear in a few minutes when we read the rest of NOAA's discussion text together, a slower filament eruption from the day before that the Space Weather Prediction Center says is highly likely to catch up to and interact with the faster eruptions behind it. That is a compound coronal mass ejection setup. We will get to what that means in detail. For now, hold one fact in your head. 3 eruptions left the sun this morning. At least 2 of them are aimed at us. The forecast for the next 72 hours, which we will also read together word for word, says quiet. The discussion text behind the forecast says something different. Let me ground the chronology in something an audience can feel. Take the moment of the M9.3 flare, that 1:36 in the morning universal time mark. In the United States, that translated to about 9:36 in the evening on Tuesday the 2nd of June Eastern Daylight Time. If you live on the east coast of America, the first eruption happened while you were watching the local news, while children were going to bed, while the day's last airline departures were lining up at the gates. You did not see it. The sun is below the horizon at that hour for the East Coast. But the high-frequency radio operators were on it within seconds, because the radio blackout signature shows up on every shortwave receiver across the sunlit half of Earth at the same instant. The M9.3 was registered by Australian listeners, by Hawaiian operators, by ham radio enthusiasts across the Pacific, all simultaneously. That radio blackout, which on the NOAA scale is rated R2 and considered moderate, was the first warning anyone outside the official monitoring chain got that the sun had done something noteworthy. The Earth-directed CME confirmation, of course, came later, after the imagery from the coronagraphs had been processed and the triangulation with stereo A had been done. The M7.7 came at 7 UTC, which was 3 in the morning on the east coast of America, dawn in Western Europe, mid-morning across most of Asia. That one happened while America slept, which meant that by the time most of you sat down with your coffee, 2 of the 3 flares had already happened. The second one had launched an Earth-directed eruption with a high radio burst, and the operational language inside the forecast discussion already contained the words modelling still ongoing. The X1 came at 11:28 UTC, which was 7:28 in the morning Eastern, 4:28 Pacific. America was awake for that one. The strongest radio blackout of the day happened while morning radio shows were on the air. Ham operators across the country reported instantaneous signal loss on 20 meters, on 40 meters, on the bands that depend on the ionosphere being where they expect it to be. The ionosphere absorbed the X-ray burst, which is what produces the blackout, and high-frequency communication across the sunlit side of Earth basically ceased to function for about an hour. The radio operators noticed. The aviation community noticed, because long-distance polar flight routes use exactly this band for communication when satellite coverage is incomplete. The military signal intelligence community noticed, because every radio anomaly of this size triggers a notification chain. The general public did not notice because the radio blackout is invisible to almost everyone except the people who depend on the equipment that it affects. Now hold all of that together. 3 flares, 10 hours, 1 sunspot. The radio signatures that tell us about the X-ray output match the optical class assigned by NOAA. The 10.7 centimetre bursts that tell us about the particle acceleration in the lower corona were 360, 540, and 250 solar flux units respectively. The Type 2 burst from the M7.7 gave us a shock velocity, which gives us a rough estimate of how fast the CME left the Sun. And the LASCO C2 coronagraph, which is the imaging instrument on the SOHO spacecraft positioned between Earth and the Sun, picked up the first 2 eruptions cleanly and is waiting on the third to enter its field of view. This is what an active solar week looks like from inside the operational forecast chain in real time. Here is the question you should already be asking. If 2 of these eruptions have been confirmed Earth-directed and a third is inbound, and the modelling is explicitly described as still in progress, what does the published forecast actually say? Why does the public-facing 3-day forecast project KP at most 3.67, which is below the threshold that NOAA calls G1 minor geomagnetic storm? Why does the official rationale in plain language read no G1 or greater geomagnetic storms are expected? We will read that document together in Part 4. We will read the discussion text that accompanies it together too, because that is where the modelling still ongoing language lives. The gap between those 2 documents is the operational story of this week. There is one piece of the chronology I want to dwell on for a moment, because it matters for how the rest of the day might unfold. The interval between the M9.3 and the M7.7 was about 5.5 hours. The interval between the M7.7 and the X1 was about 4.5 hours. The intervals are getting shorter, the X-ray output is getting larger. The radio bursts associated with each event are giving us a sequence of values that, taken together, paint a picture of a region that is not relaxing back to a quiet state. It is escalating. When solar physicists look at a sequence like this in real time, the question they ask is whether the next event is going to come even sooner and even bigger. The pattern of decreasing inter-event intervals combined with increasing X-ray class is the signature of a sympathetic flaring sequence in an active sheared configuration. Not all such sequences continue. Some peter out after a few events as the configuration finds a stable lower energy state. Some continue for days, with multiple X-class events in succession, before the underlying flux emergence finishes. We do not know, as I am recording this, which pattern region 4455 is on. The next 12 hours will tell us. If we see another M-class event before the day ends, the sequence is probably continuing. If we see another X-class event in that window, the sequence is almost certainly continuing. If the region quiets down after the X1 this morning, the sympathetic sequence has likely run its course for now. That uncertainty about the next 12 hours is one of the operational reasons the published forecast contains the modelling still ongoing language. The published KP 3.67 covers the next 3 days, but the assumed input to that projection includes only the 3 flares that have already happened. If a 4th event occurs while the 3 already launched CMEs are still in transit, the operational picture becomes considerably more complex. A 4th CME, if it is also Earth-directed, would interact with the existing inbound stack in ways that would further complicate the merger geometry that we will spend Part 5 working through. But before we can get to the forecast, we have to talk about the sunspot that produced these eruptions, because region 4455 is doing something that almost no sunspot in this solar cycle has done. It is breaking a rule that was written down in 1919, a rule that, until this week, was holding for 97% of the sunspots in this cycle. A rule that almost no one outside the discipline of solar physics has ever heard of. We are going to spend some time on this because it is the why behind the what, and because it is going to come up again when we land on what should actually happen in the next 72 hours. Part 2. The sunspot that shouldn't be doing this. In 1919, an American astronomer named George Ellery Hale wrote down a rule about sunspots that had not been written down before. Hale was already one of the most consequential observational astronomers of his era. He had built 3 of the largest telescopes that had ever been constructed by humans, including the Mount Wilson 60-inch and the Mount Wilson 100-inch, the latter of which would shortly thereafter be used by Edwin Hubble to discover that the universe was expanding. Hale had also, in 1908, become the first person to ever measure a magnetic field outside of Earth. By recognizing that the dark splits in the spectral lines of sunlight that came from sunspots were caused by the same Zeeman effect splitting that physicists were producing in laboratories on Earth using powerful electromagnets. He had, in other words, looked at a sunspot and recognized that what he was seeing was an enormous magnetic structure punched through the surface of the sun. From that recognition, over the next decade, he and his collaborators worked out something extraordinary. What they found was that sunspots almost never appear alone. They appear in bipolar pairs, with a leading spot and a trailing spot, with the leading spot oriented in the direction the sun rotates. The 2 spots in a pair are connected by an arch of magnetic field, with one spot serving as the positive pole and the other as the negative pole, and the leading spot in a pair, the one out in front in the direction of solar rotation, is the spot that carries a specific magnetic polarity that is consistent across the entire hemisphere during a given solar cycle. In the northern hemisphere of the Sun during one cycle, leading spots are negative. In the southern hemisphere of the same cycle, leading spots are positive. Then, 11 years later, when the next solar cycle begins, the polarities flip. Northern leading spots become positive. Southern leading spots become negative. 11 years later again, they flip back. This 22-year cycle of polarity reversal is now known as the Hale cycle, after the man who discovered it. And the rule that the leading spot in a sunspot pair carries a specific polarity that is consistent across a hemisphere during a cycle is now known as Hale's polarity law, or Hale's law. Hale's law has been holding, with very high reliability, for every solar cycle we have observed in detail since 1919. In the current solar cycle, which is solar cycle 25, the leading polarity in the northern solar hemisphere is positive. That means, in this cycle, a northern hemisphere sunspot pair should have a positive leading spot to the west, in the direction of solar rotation, and a negative trailing spot to the east. That is the rule. It is the dominant orientation for almost every sunspot pair that has emerged this cycle. But not every sunspot pair follows the rule. There are exceptions. A small percentage of bipolar sunspot groups that emerge during any given cycle carry a leading polarity that is reversed relative to the dominant Hale orientation for their hemisphere. These exception cases are called anti-Hale regions. Their leading polarity is wrong, their magnetic configuration is reversed. They emerge through the photosphere with their bipolar axis tipped against the prevailing tilt of the surrounding magnetic field. They are the wrong-way regions. They are statistically rare. Across solar cycle 23 and solar cycle 24, the published statistical work suggests that anti-Hale sunspot groups make up about 3 to 5% of the total bipolar population. In some studies, the number is closer to 4%. In others, depending on the criteria used for what counts as a true anti-Hale violation, the number is closer to 7%. Either way, the rule holds for 93 to 97% of the sunspot pairs on the Sun. The remaining few percent are the exceptions. You can already feel where this is going. Region 4455, the sunspot complex that has produced the 3 major flares we just walked through, is one of those exceptions. The Space Weather Prediction Center's discussion text, which is a publicly available document published twice a day at NOAA's Space Weather website, contains the following sentences about Region 4455. I'm going to read them to you in their original form, in the order they appear in the document, with one comment in between. Quote, Region 4455 remains complex, displaying an anti-Hale configuration caused by a series of small negative polarity spots developing south and west of its mature positive spot. These spots exhibited continuous flux emergence, causing a very mixed polarity area with substantial shear, likely the source of the high-level M-class flaring from that region. End quote. That single paragraph contains everything you need to know about why this sunspot has spent the past 10 hours producing flares that the forecast did not fully anticipate. The mature positive spot in the region is the spot that has been there for several days. It rotated into view from behind the eastern limb of the Sun in late May, and as the Sun's rotation brought it westward across the disk, it grew. Then, in the past few days, a series of small negative polarity spots began emerging through the photosphere south and west of that mature positive spot. Because the positive spot is itself the wrong polarity leading spot for an anti-Hale configuration in this cycle, the new negative polarity emergences are also in the wrong arrangement relative to the prevailing Hale orientation. They are emerging with shear, which means that the field lines connecting them to the mature spot are stretched and twisted, accumulating magnetic energy. What is happening here, in physical terms, is that the rising magnetic flux tube that produced this sunspot region is not aligned with the dominant tilt of the subsurface magnetic field. The standard explanation, which goes back to work by Babcock and Layton and was refined in the 1970s and 1980s, is that sunspots form from buoyant rising flux tubes generated by the solar dynamo deep below the photosphere. Those flux tubes, as they rise, are subject to the Coriolis force, which gives them a characteristic tilt as they break through the surface. The tilt is Hale compliant on average, because the dynamo and the rotation conspire to set it up that way. But not always. Sometimes the tilt comes out the wrong way, perhaps because of a particularly turbulent local condition deep in the convection zone, perhaps because of stochastic variation in the flux tube dynamics. When that happens, the region emerges anti-Hale. And here is what makes anti-hail regions matter. McClintock and Norton, in a 2016 paper in the Astrophysical Journal, did a careful statistical analysis of the anti-hail population across solar cycle 23 and solar cycle 24. They found something that has been confirmed by subsequent work, including a more detailed paper by Munoz Jaramillo and collaborators in 2021. Anti-hail regions, despite being only 3 to 5% of the total bipolar sunspot population, are statistically overrepresented in major flare production. They produce more X-class and M-class flares per unit area than hail-compliant regions do. The simplest physical explanation is that an anti-hail region, by virtue of being misaligned with the dominant background field, accumulates shear as it grows. The mismatch between its own polarity tilt and the prevailing field forces continuous flux emergence to occur into a sheared geometry. Every new bit of emerging flux adds to the magnetic energy stored in the configuration, and when the configuration releases that stored energy through magnetic reconnection along the sheared neutral line, the resulting flare tends to be more energetic than a comparable flare from a hail-compliant region. This is the physics behind what you watched happen this morning. Region 4455 is a wrong-way region. It is accumulating shear because of its wrong-way orientation. It is emerging new flux that adds to the shear instead of relieving it, and, like other anti-hail regions before it, it is releasing the accumulated energy in flares that punch above the weight class of its sunspot count. 3 major flares in 10 hours, with all 3 reaching M-class or higher, with one of them reaching X-class, from a region that has 17 spots and an area of 330 millionths of the solar hemisphere. Those are not extraordinary numbers in terms of size, but the productivity per unit area, given the magnetic configuration, is consistent with what the statistical literature predicts for an active anti-hail region during its peak flux emergence phase. Now let me put that in audience terms. The Sun produces sunspots all the time. Most of them follow the rule that George Ellery Hale wrote down 107 years ago. About 1 in 20, give or take, breaks the rule. And of the ones that break the rule, a disproportionate share of the major flares of any given solar cycle come from those exceptions. The reason no one outside of professional solar physics has ever heard the term anti-hail is that the regions are rare, and the productivity, while statistically elevated, is not so dramatic that you can predict it region by region. You can predict the population. You cannot predict which individual region will go big. Region 4455 right now is going big. And the Space Weather Prediction Center, in its discussion text, is telling us why. There is one more piece of the anti-hail story that matters for this morning, and that is the question of whether the productivity tends to come in clusters. The work by Munoz Jaramillo and collaborators in 2021 suggests that anti-hail regions, when they go active, tend to keep going active. The same configuration that produced the first major flare tends to produce additional major flares within hours or days, not weeks, because the underlying flux emergence is continuing, and because the energy storage and release dynamics in a sheared configuration can produce multiple eruptions in sequence as the system relaxes step by step. We saw 3 flares in 10 hours this morning. The published flare probabilities for the next 24 hours from the Space Weather Prediction Center assign region 4455 a 40% chance of producing another M-class event and a 10% chance of producing another X-class event. Those probabilities are calibrated to the full sunspot population. The anti-hail subset, statistically, produces at rates above those baselines. The honest forecast, the one the discussion text is telling us by implication, is that we should not be surprised if region 4455 does this again within the next day. We should be moderately surprised if it does not. There is one more layer to the anti-hail story that needs to be on the table, because it explains why the morning's 3 flares all came from the same region in such tight succession. The mechanism is called sympathetic flaring. When a sunspot complex stores energy in a sheared magnetic configuration, the first major reconnection event in that configuration relaxes one set of field lines, but does not necessarily relax the entire configuration. The remaining sheared field lines can reorganize in the wake of the first event, with the released energy from the first reconnection partially restructuring the field topology of the neighboring sheared regions. If the restructuring brings a second sheared neutral line into a configuration that can reconnect, a second flare follows. If the second flare restructures a third flare follows. This is the operational picture for what is sometimes called a homologous flare sequence, and region 4455 today is producing close to a textbook example of one. The M9.3 at 1:36 UTC, the M7.7 at 7 UTC, the X1 at 11:28 UTC, 3 flares, increasing in X-ray output from the same region in the same configuration within 10 hours. That sequence pattern is consistent with sympathetic flaring driven by progressive relaxation of an extensively sheared anti-hail configuration. What it means for the rest of the day and for the rest of the week is that the configuration of region 4455 may not be done. The sympathetic flaring sequence can extend further if the underlying flux emergence continues and if the remaining sheared field lines provide opportunities for additional reconnection. The Space Weather Prediction Center's published 40% M-flare probability and 10% X-flare probability for region 4455 over the next 24 hours is, in my read of the statistical literature, almost certainly on the conservative side for an active sympathetic sequence in an anti-hail region at this stage of its evolution. The honest framing is that we should not be surprised if region 4455 produces another M-class flare or even another X-class flare before the day is over. We should be moderately surprised if the region simply quiets down without further activity. I want to give you one historical analogue before we move on, because it grounds what we are watching today in a comparable case the audience may remember. In October of 2024, during the peak of solar cycle 25, region 3869 emerged as a complex magnetic configuration on the eastern limb of the visible disk. Within a week it had produced multiple X-class flares, multiple Earth-directed CMEs, and it ultimately contributed to the G5 geomagnetic storm of October 10th and 11th, 2024, the most intense geomagnetic event in roughly 2 decades. Region 3869 was not anti-hail, but it was a Delta-class region with extreme magnetic complexity, and the flaring sequence it produced was a homologous sequence in many of the same ways that region 4455 is producing today. The published forecasts for the October 2024 events were also revised upward multiple times across the week, as the model output caught up to the rapidly changing disk. The pattern of headline forecast issued then revised is the pattern we may be entering with the current region 4455 sequence. The difference this time is that the anti-hail configuration adds an additional layer of statistical priors to what should be a conservative interpretation of the published forecast. The statistical overrepresentation of anti-hail regions in major flare production, documented by McClintock and Norton in 2016 and Munoz Jaramillo and collaborators in 2021, is the kind of finding that operational forecasters know about, but that the headline numbers do not always reflect. The published forecast is calibrated to the full sunspot population. The anti-hail subset, when active, performs above the published baselines. We are watching, right now, in real time, a confirmed anti-hail region in an active sympathetic flaring sequence. The right way to read the published forecast is as a lower bound, not as a centre estimate. That brings us to the second part of the equation. Region 4455 is not alone on the visible solar disk. There are, as of the morning forecast discussion on June 3, 2026, 4 other numbered sunspot regions that have developed gamma magnetic configurations in the past 24 hours. We are going to talk about each of those regions in Part 7, because they matter for what the next several days look like. But first, we need to do something else. We need to bring this story back to where the audience watching this video has been for the past 4 days. We need to talk about the fireballs. Part 3. 5 fireballs, then this. In yesterday's video, we walked through what we were calling 5 fireballs in 4 days over America. We walked through the Cape Cod bolide of May 30th, when a 5.5-ton stony meteoroid hit the atmosphere above Cape Cod Bay at 42,000 miles per hour and broke apart 31 miles above the water. We walked through the NASA Marshall confirmation chain that resolved the case in 48 hours via the GOES-19 geostationary lightning mapper. We walked through the Midwest and Great Lakes fireball of June 1st, captured on the Wadsworth, Ohio dashcam, captured on the Cary, Ohio 13ABC affiliate via Chris Palka, captured on the Chicago EarthCam at 10:41 Central Daylight Time facing west toward Lake Michigan. We walked through the Maine Green fireball of the same evening, captured on the Starlive streaming camera at Sebec Lake. We walked through the 7-state eyewitness band of corroborating reports across Ohio, Michigan, Indiana, Illinois, Wisconsin, Pennsylvania and Kentucky, plus Ontario. We grounded the cluster in the CNEOS Fireball and Bolide reports catalogue. We anchored the statistical baseline at approximately 80 to 100 events per year, globally above the catalogue's 0.073 kiloton detection threshold, of which approximately 2 to 5 per year are over the continental United States in the kiloton class range. We ran the Poisson-Tail probability and landed at a 4-day cluster of this density occurring somewhere in the US catalogue approximately once every 25 to 40 years under the null hypothesis of independent arrival times. We landed on the conclusion that the cluster was real, the events were real, the physics was well understood, and the cluster sat at the high end of normal statistical variation, but not outside it. We landed on the editorial framing that the interesting question was not what hit us, but rather what it means that we can now see this happening in real time across the entire continent through dashcams and webcams and live streams and social media aggregation. Now, today, the same audience that spent 4 days watching the sky is being asked to interpret something else. 3 solar flares from a single wrong-way sunspot, 2 confirmed Earth-directed coronal mass ejections, a third inbound, a compound interaction setup with a slower filament that left the sun yesterday, a forecast that says quiet, and a discussion text that says the modelling is still in progress. I want to be very clear about something before we go any further. The fireball cluster of the past 4 days and the solar flare sequence of this morning are physically unrelated phenomena. There is no causal connection between meteoroids entering Earth's atmosphere and solar flares emerging from a specific sunspot region 150 million kilometres away. There is no mechanism by which the entry of a 5.5-ton stony rock above Cape Cod Bay on May 30th could influence the magnetic dynamics of a sheared anti-hail flux tube on the surface of the Sun. There is also no mechanism by which a solar flare from region 4455 could cause specific near-Earth objects on independent heliocentric orbits to choose to enter Earth's atmosphere within the same calendar week. The two phenomena proceed from entirely separate physical drivers in entirely separate parts of the solar system, on entirely separate timescales, through entirely separate mechanisms. They're unrelated. Period. But the temporal coincidence is real, and the experience of the audience that has been watching the sky over America for 4 days, who now finds itself being told that the sun has just launched 3 eruptions from a magnetically reversed sunspot, is also real. So we have to do 2 things in this video that go in opposite directions at the same time. We have to honour the audience's pattern recognition instinct, because that instinct is the reason you are still watching, because that instinct is the reason this channel exists, and we have to land you, before the video's over, on the right answer about what is actually happening above us. The right answer is that the universe is doing its routine work, that the universe has always been doing its routine work, and that the new thing in our era is not the work itself, but our ability to watch it all happen at once, in continental scope, through dashcams and coronagraphs and X-ray monitors, and operator-issued forecasts that go from a quiet headline to a modelling still ongoing caveat in the same morning. If you were to ask me what the most interesting fact about this week is, I would tell you it is not that fireballs and solar flares happened in the same calendar window. That coincidence, while statistically rare, is exactly the kind of rare coincidence that statistical models predict will happen sometimes, when you wait long enough, in a sky that is full of activity. The interesting fact is that we have built a planetary observation infrastructure dense enough to catch all of it. 5 fireballs over the eastern United States in 4 days, 3 of them documented by consumer dashcams and citizen live streams, 1 of them attributed within 48 hours by NASA Marshall via a satellite instrument that was originally designed to find lightning, and, simultaneously, 3 solar flares attributed within minutes by NOAA sub-PC via X-ray telescopes that are themselves currently running on the backup spacecraft, because the primary spacecraft is offline, with the resulting CMEs being characterized by triangulation between 2 coronagraphs separated by tens of millions of kilometers across interplanetary space. We are watching the routine work of the universe with more instruments than any generation that came before us. That is what this week is showing you. Not a conspiracy, not a coordinated cosmic event, a coincidence, made visible. And one more honest framing before we move on. The audience that has been watching the sky for 4 days is, by this point in the week, in a heightened pattern recognition state. That is not a flaw in the audience. That is the way human cognition works under conditions of repeated salient stimulus. When you have seen 5 fireballs in 4 days, and you're now seeing 3 solar flares in 10 hours, your brain will try to connect them. That instinct is the same instinct that kept your ancestors alive when the wolves came back 2 nights in a row, when the storm clouds came back 2 seasons in a row. The instinct is good. The instinct is doing exactly what it was built to do. The job of a documentary on a science channel when faced with that instinct is to honour it by acknowledging it directly, and then to walk you through the physics that resolves it, which is what we are about to do. So here is the structure of what is coming. In the next part, we're going to read NOAA's published forecast for the next 72 hours. We're going to read it together, word for word, in the order it appears in the document, with the headline first and the rationale after. Then we're going to read the discussion text that accompanies it, again word for word, in the order it appears, with the modelling still ongoing language in its proper place. And then we're going to talk about what the gap between those 2 documents actually means, operationally, for what the next 3 days might look like. After that, we're going to talk about the filament from yesterday, and what a compound coronal mass ejection actually is, and why the published forecast cannot yet account for the merger. Then we are going to talk about the GOES 18 sensor outage, because that is part of the operational picture this week, and because you deserve to know what instrument is and is not being used to characterise what is hitting your atmosphere. Then we're going to talk about the other 4 sunspot regions that have developed gamma configurations on the visible disk in the past 24 hours, because the disk is densely populated with primed flare producers right now, and that affects what the rest of the week could look like. Then we're going to do a brief sweep of everything else that has happened this week, from the Mendocino Triple Junction earthquake sequence to the end of NASA's MAVEN Mars mission to the early season Pacific tropical setup, because the sky is busy in more than one direction. And then, finally, we're going to land on what is actually happening above us and what we should make of all of it together. If that sounds like a lot, it is. This is a week that has earned a long answer. Let us keep going. Part 4. The Forecast and the Caveat. The document I am about to read to you is publicly available. You can find it on the National Oceanic and Atmospheric Administration Space Weather website. It is called the 3-Day Forecast. It is issued twice a day, at 0030 and 1230 Universal Time. The version we are working from was issued at 1230 UTC on June 3rd, 2026. By that hour, the M9.3 flare had already happened. The M7.7 flare had already happened. Their associated CMEs had already been imaged in the LASCO C2 coronagraph and triangulated as Earth-directed. The X1 flare was about an hour past its peak. The radio blackout it caused was still being characterized. Here is what the document says. Section A, NOAA Geomagnetic Activity Observation and Forecast. The greatest observed 3-hour KP over the past 24 hours was 3, below NOAA scale levels. The greatest expected 3-hour KP for June 3rd through June 5th, 2026, is 3.67, below NOAA scale levels. The forecast then breaks down the KP by 3-hour interval for each of the 3 days. The peak KP across the entire 72-hour forecast window is 3.67, reached during the 00 to 03 UTC interval on June 4th, and again during the same interval on June 5th. Every other interval is lower. Most of the forecast intervals are between 2 and 3. Then comes the rationale. The rationale is 1 sentence long. Quote, "No G1 minor or greater geomagnetic storms are expected." End quote. That is the headline forecast for the next 3 days. Geomagnetic activity below G-scale levels. No storms expected. The number that goes onto your space weather app, the number that goes onto the cable news Chiron if any cable news outlet covers space weather today, the number that goes into the brief paragraph on the NOAA homepage is KP 3.67. The takeaway from that number, for anyone reading at headline speed, is that the next 3 days will be quiet. Now I want to read you the rest of the document, because the rationale that says no G1 or greater storms are expected is in the same document as several other things that the headline does not capture. Section B is the Solar Radiation Activity Observation and Forecast. It says the radiation environment is below S-scale levels, with a 5% chance of SWAN or greater each day. That is consistent with the proton flux data we have in the briefing, which shows greater than 10 MeV proton flux at 0.36 particles flux units, well below the S1 threshold of 10 particle flux units. So the radiation environment is genuinely quiet, in part because the source region for the major flares this morning was at heliographic position north 14 west 16, which is not optimally connected via the Parker spiral magnetic field structure to Earth's orbit. The proton acceleration that you would expect from an X-class event in a more western position did not happen here. Section C is the radio blackout activity and forecast. The forecast for the next 3 days is R1 to R2 at 55% each day, with R3 at 10% each day. The rationale is one sentence. Quote, R1 to R2 minor to moderate radio blackouts are likely, with a slight chance for R3 strong or greater events through 5 June. End quote. The R3 that happened at 11:28 this morning, the one associated with the X1 flare, is consistent with that forecast. The radio blackout part of the prediction is operating as designed. The forecast said there was a 10% chance of R3 each day for the next 3 days. One of those 3 days has had its R3. That is exactly the kind of event that a 10% probability forecast predicts will happen sometimes. So if the radio blackout forecast is working, and the solar radiation forecast is working, where is the modelling still ongoing language? It is in the next document, which is also publicly available, which is also published twice a day, which is called the Forecast Discussion. The Forecast Discussion is the prose document that accompanies the 3-day forecast. It explains the reasoning behind the numbers. It is where the operational meteorologists at the Space Weather Prediction Center write down what they are seeing, what they are inferring, what they are not yet sure about. It is, in space weather forecasting, the equivalent of the area forecast discussion that an NWS office puts out alongside the surface forecast. It tells you what the forecaster is thinking. And on June 3rd, 2026, what the forecaster was thinking included these 3 pieces. The first piece is about the M9.3 flare and its CME. Quote, the M9.3 was accompanied by a Type 4 radio sweep and a 10.7 cm radio burst, peaking at 360 solar flux units. An associated CME became visible in LASCO C2 coronagraph imagery at approximately 0213 UTC. The structure is very faint, but GOES SUV imagery suggests that the structure is a partial to full halo, and triangulation with stereo coronagraph imagery indicates there is an Earth-directed component. Modelling is still ongoing. End quote. That is the first time the words modelling is still ongoing appear in the discussion text. They appear after the confirmation of the Earth-directed component. They appear in the same sentence as the words very faint. They mean that the operational forecasters know there is something coming at us. They know it left the sun a few hours ago, they know it has an Earth-directed component, and they have not yet finished working out how fast, how strong, and when. That information was not available at the time the 3-day forecast was published. The second piece is about the M7.7 flare and its CME. Quote, the M7.7 was also accompanied by a 10.7 cm radio burst, this one peaking at 540 solar flux units, and a Type 2 radio burst with an estimated shock velocity of 313 km per second. An associated CME became visible in LASCO C2 imagery at approximately 0748 UTC. Both coronagraph and GOES SUV imagery suggest that the bulk of this eruption may have been deflected northward due to the nearby coronal hole. Triangulation with stereo also indicates this CME has an Earth-directed component. Modelling is still ongoing. End quote. That is the second time the modelling still ongoing language appears. It appears after a more detailed acknowledgement than the first one. It tells you that some of the eruption was nudged northward by a coronal hole, but it tells you that part of it is still coming at us, and it tells you again that the modelling has not been finished. The third piece is about a separate event, which we'll go into in detail in Part 5. Quote, modelling of a large filament eruption from the southwest from earlier in June, second confirms no Earth-directed component. However, its timing, source location, and relatively slow velocity mean that it has a high probability of interacting with the faster CMEs behind it and changing their propagation into the near-Earth environment. End quote. That is the third piece. It is talking about a slower eruption that left the sun yesterday, June 2nd. It is telling you that the eruption itself is not aimed at Earth, but it is also telling you, in language that is unusually direct for a forecast discussion document, that this slower eruption is highly likely to interact with the faster eruptions behind it. The two faster eruptions, the ones with confirmed Earth-directed components, are the ones we just walked through. The slower eruption from yesterday is between them and us. The compound CME setup that we will spend part 5 on is right there, in plain language, in the public discussion document. So here is where we are. The 3-day forecast says KP at most 3.67, no G-scale storms expected, geomagnetic activity quiet through June 5th. The forecast discussion says 2 confirmed Earth-directed CMEs, modelling still ongoing for both, a slower filament eruption highly likely to interact with the faster eruptions behind it. Both documents are public. Both documents are published twice a day. Both documents are signed by the same office. And both documents are telling you different things about what the next 72 hours could look like. This is not a conspiracy. This is not a cover-up. This is not the Space Weather Prediction Center hiding what is coming. This is the way operational forecasting works. The 3-day forecast is a summary product. It has to commit to a number. It cannot embed the full uncertainty of a CME that has not yet been fully modelled. The forecast discussion is the document that handles the uncertainty. That is where the operational reasoning lives. That is where the open questions live. That is where the words modelling is still ongoing live. The honest framing, the one this channel exists to give you, is that they are telling you. The information is in the public record. The caveat is right there. The problem is not that the Space Weather Prediction Center is hiding the uncertainty. The problem is that almost no one reads past the headline. Most coverage of space weather, when it gets covered at all, quotes the KP number and the G-scale and the no storms expected sentence. The discussion text, where the model status is described in plain language, is treated as inside baseball, as too technical, as the kind of thing only space weather professionals read. That is what this video is for. We are reading the discussion text together. We are giving you the operational picture that the headline does not contain. And we are telling you, plainly, that the published KP 3.67 forecast was made before the modelling of the day's 3 Earth-directed eruptions was complete. The published forecast is the best estimate available at the moment it was published. It is provisional, it is going to be updated, and when the modelling is finished, in the next 24 to 48 hours, the updated forecast may say something different. There is a piece of context here that connects directly to what we did yesterday with the fireball cluster. Yesterday we explained how the federal detection chain for atmospheric meteoroid entries has 2 layers. The first layer is the GOES-19 geostationary lightning mapper, which catches the brighter daylight bolides like Cape Cod and confirms them within 48 hours. The second layer is the American Meteor Society pending fireball reports queue, which aggregates citizen witness reports of nighttime bolides over a multi-day to multi-week catalogue timeline. The 2 layers operate at different speeds, with different evidentiary thresholds, and they produce different attribution timelines for events that may have very similar underlying physics. Yesterday we walked through how that asymmetry produces the editorial appearance of a federal disclosure gap, when in fact what is happening is that the structural detection chain is operating at its designed timescales. The exact same structural pattern is what we are looking at now with the space weather forecast chain. The 3-day forecast is the headline product, the equivalent of the GOES-19 GLM rapid catch. It commits to a number within hours of the events it covers. The forecast discussion is the deeper analytical product, the equivalent of the AMS pending fireball reports queue, the document where the open questions live and where the modelling status is described in its full uncertainty. Both documents are public. Both are published twice a day. The headline gets quoted. The discussion gets read by almost no one outside the operational forecasting community. The asymmetry between what the federal infrastructure actually publishes and what reaches the public is the same asymmetry, structurally, in both the fireball case yesterday and the solar case today. The infrastructure is being transparent. The headlines are not depth-loaded. The full picture is in the public record. The audience just has to know where to look. I want to add one more layer here, because the audience deserves to understand the institutional reality of what the Space Weather Prediction Center is and what it does. The SWPC operates 24 hours a day, 365 days a year, out of Boulder, Colorado. It is staffed by trained space weather forecasters who work on rotating shifts to provide continuous coverage of solar activity, geomagnetic conditions, ionospheric disturbances, and radiation environment. The center's primary external customers include the Federal Aviation Administration for Polar Route Guidance, the North American Aerospace Defense Command, and the United States Space Force for Satellite Operations, the Federal Energy Regulatory Commission, and the North American Electric Reliability Corporation for Power Grid Impact Assessments, the GPS Wing for Navigation Accuracy Advisories, and the broader civilian and commercial satellite community for orbital safety. When the SWPC issues a forecast, that forecast is consumed by operational systems that take action based on it. The forecast is not theoretical. The forecast has real-world consequences for systems that hundreds of millions of people depend on every day. That is part of why the modelling still ongoing language matters. The SWPC's operational customers need a published number. The grid operators need a KP projection so that they can plan their reactive power reserves. The polar aviation routing teams need a radio blackout forecast so that they can plan their high-frequency communication backups. The satellite operators need a radiation forecast so that they can position their solar arrays to manage attitude control. Those operational customers cannot wait for the modelling to complete before they act. They need a number now. The published KP 3.67 is the number they get. The modelling still ongoing language tells them, in the discussion text, that the number is provisional and may update. The combination of a headline now plus caveat in discussion is the operational compromise that lets the system function under the inherent uncertainty of compound CME forecasting. The audience watching this video in this sense is not separate from those operational customers. You are at the end of the same chain. The forecast that goes to the grid operators is the same forecast that goes to your space weather app. The forecast that goes to the polar aviation routing teams is the same forecast that gets quoted in any cable news segment that covers solar activity today. The forecast that goes to the satellite operators is the same forecast that determines whether the auroras will be visible from your backyard tonight. You're inside the operational consumer chain, whether you knew it or not. The infrastructure is built to serve you. The information is built to be accessible to you. The depth is there for you to read, if you know to read it. What might the updated forecast say? That is what Part 5 is for. Because to understand what an updated forecast might look like, we have to understand what a compound coronal mass ejection actually is, and why the interaction of 3 faster CMEs catching up to one slower filament-driven structure changes the arithmetic of what arrives at Earth and when. Part 5. The filament behind them. There is a kind of solar event that almost never makes the news, because by itself it does not produce a flare, and it does not produce a radio blackout, and it does not light up the X-ray monitors. It just looks like a long, dark thread peeling itself off the surface of the sun. That is a filament eruption. Filaments, when you see them in extreme ultraviolet imagery from the SDO spacecraft, look like ropes of cooler plasma suspended above the photosphere by magnetic fields. They can be enormous. They can stretch across hundreds of thousands of kilometers of the solar disk. They are unstable, and every so often the magnetic configuration that has been holding one of them in place loses tension, and the whole filament rises off the sun and becomes part of a coronal mass ejection that drifts outward through the heliosphere. A filament eruption is, in physical terms, a slow CME. It is not necessarily associated with a flare, because the energy release in a filament eruption is distributed across the rising flux tube rather than concentrated at a reconnection point. The CME that emerges from a filament eruption tends to be slower than the CMEs that come from impulsive flare events. Where a fast CME associated with an X-class flare might be moving at 1500 or 2000 km per second when it leaves the sun, a filament-driven CME might be moving at 300 or 400 km per second. That speed difference matters. It is the difference between a CME that reaches Earth in 15 hours and a CME that reaches Earth in 40 hours. It is the difference between a CME that arrives ahead of the next one and a CME that arrives behind the next one. On June 2nd, 2026, the day before this morning's triple flare sequence, a large filament erupted from the southwestern quadrant of the visible solar disk. The Space Weather Prediction Center modeled the eruption and determined that the resulting CME did not have an Earth-directed component. The plasma cloud was moving outward in a direction that did not point at our orbital position. By itself, it would have been a footnote, a slow, filament-driven CME going somewhere other than Earth. not affecting anyone in our planet's frame of reference, the kind of event that solar physics tracks, but that the public never hears about. Except, less than 24 hours after that slow filament left the Sun, 3 fast eruptions left the same Sun, 2 of them with confirmed Earth-directed components, and a third inbound. The 3 fast eruptions are moving outward into a region of the heliosphere that the slower filament has just passed through. The geometry is the classic geometry of a compound coronal mass ejection. A slower cloud out ahead, faster clouds behind it, the faster clouds catching up. The interaction happening somewhere in interplanetary space between the Sun and Earth. This is the geometry the Space Weather Prediction Center is describing when it writes, quote, "Its timing, source location, and relatively slow velocity mean that it has a high probability of interacting with the faster CMEs behind it and changing their propagation into the near-Earth environment." End quote. The slow, filament-driven CME is in the way. The faster, eruption-driven CMEs are coming up behind it. They are going to merge. When 2 or more CMEs merge in interplanetary space, the resulting structure is called a compound CME. The first published analyses of compound CMEs go back to work by Gopal Swamy and collaborators in the early 2000s, but the canonical reference for the geomagnetic consequences is a 2014 paper in the Astrophysical Journal by Liu and collaborators titled "Observations of an Extreme Storm in Interplanetary Space Caused by Successive Coronal Mass Ejections." That paper, and the body of follow-on work that has come from it, established several things that are now part of the operational understanding of how compound events behave. The first thing is that compound CMEs produce a disproportionate share of major geomagnetic events. Across solar cycle 23, approximately 40 to 60% of the G4 to G5 geomagnetic storms, which are the storms that produce auroras at low latitudes and that stress power grids, were caused by compound CME structures rather than single CME arrivals. That number is large because the merger physics tends to amplify the geomagnetic effectiveness of the combined event. The faster trailing CME, when it catches up to the slower leading CME, can compress the leading structure's magnetic field. That compression strengthens the field, and when the combined structure arrives at Earth, it carries a stronger and more sustained southward magnetic field component than either of the original CMEs would have carried alone. The second thing is that compound CMEs are harder to forecast than single CMEs. The geometry of the merger depends on the relative speeds of the leading and trailing structures, on their angular separation, on whether they are aligned along the same heliospheric flow line, on the local solar wind conditions in the region where the merger happens. None of those parameters are directly observable from Earth. Some of them can be inferred from coronagraph imagery, particularly when you have triangulation between LASCO at Earth and stereo at a different vantage point. But the inference is not perfect. The modelling tools that are used operationally, including the NLIL model that the Space Weather Prediction Center uses, can simulate compound interactions, but they require initial conditions that are not always well constrained from the available imagery. The longer the modelling takes, the better the constraints. That is part of why the discussion text says modelling is still ongoing. The forecasters are waiting for the imagery to give them more constraints. They are waiting for the trailing CMEs to evolve far enough out from the Sun that their geometry becomes clearer in the coronagraph data. The third thing, and this is the one that matters for the next 72 hours, is that compound CMEs can produce geomagnetic effects that exceed what any single component would have produced. The published forecast, which is based on the modelling state at 12:30 UTC this morning, projects KP at most 3.67. That projection is consistent with the assumption that the Earth-directed components of the M9.3 CME and the M7.7 CME are weak, partial, possibly glancing. But that assumption was made before the modelling was complete. If the compound interaction with the June 2nd filament concentrates the magnetic flux into a more compact structure, if the resulting merged CME carries a sustained southward field component on arrival, if the timing of arrival happens to coincide with already elevated geomagnetic conditions from any other source, the KEP could come in considerably higher than the published 3.67. How much higher? The honest answer is that the modelling at the time of this video's production has not been completed. We do not know. The probability of a G1 minor storm is not zero. The probability of a G2 moderate storm is non-zero. The probability of a G3 strong storm is small but not negligible. The probability of anything higher than that is very small, but importantly, the probability mass is all on the upside of the published headline forecast. The published forecast cannot underestimate the eventual KP by very much on the low side, because the M9.3 CME and the M7.7 CME were both characterized as having Earth-directed components, and the proton flux and the radio burst both indicated meaningful eruption energetics. The published forecast can underestimate on the upside, however, because the compound interaction has not been fully simulated. The next 24 to 48 hours will resolve this. The Space Weather Prediction Center will issue updated forecasts as the modelling completes. The discussion text will replace the modelling still ongoing language with whatever the model output ends up showing. If the updated forecast comes in at higher KP than the headline, the alert chain will activate. If it comes in at the same KP as the headline, the audience will get the comfort of knowing that the published forecast was correct. Either way, the resolution is coming. There is one more piece of context that matters here. Even if the eventual arrival produces only a G1 minor storm, the visual consequence for the United States could include auroras visible at lower latitudes than is typical. G1 is the lowest geomagnetic storm category, but it is enough to push auroras down into the northern tier of states. Northern Maine, northern Minnesota, northern Washington, northern North Dakota, parts of New York, parts of Michigan. If the storm comes in higher, say G2, the auroras can be visible significantly farther south. G3 is auroras down into the mid-Atlantic. G4 is auroras in the southern United States. The May 2024 auroras, which produced photos from Texas and Mexico, were a G5 event. Nothing in the modelling so far suggests we are heading for anything remotely close to G5 today, but the gradient from G1 to G2 to G3 is the gradient on which the auroras you might be able to see from your backyard sits. The audience that has been watching the sky for 4 days for fireballs may end up watching the sky again for something else. There is one historical compound CME event that I want to put on the table here, because it serves as the operational reference case for what a compound interaction at the scale we are looking at this week could potentially produce. In July of 2012, a series of CMEs left the Sun in rapid succession from an active region rotating across the visible disk. The combined event when it reached the location of the Stereo A spacecraft was measured directly in situ, because by sheer luck Stereo A was positioned in the path of the merged structure rather than at Earth. The in situ measurements documented magnetic field strengths exceeding 100 nanoteslars, southward Bears components of 50 nanoteslas sustained over more than 12 hours, and bulk solar wind speeds in excess of 2,000 km per second. The published analyses by Baker and Liu and others estimated that if the merged structure had arrived at Earth instead of at Stereo A, the resulting geomagnetic storm would have been a G5 event comparable to or exceeding the Carrington event of 1859. The forecasting infrastructure that existed in 2012 would not have been able to predict the severity of the impact more than several hours in advance. The merger physics, in retrospect, was the dominant factor in producing the extreme parameters. I am not telling you that this week's compound CME setup is going to produce a Carrington-level event. I do not think it will. The energetics of the individual eruptions this morning, while significant, are not at the scale of the July 2012 event. The M9.3, the M7.7, and the X1 are all major flares, but they are not extreme outliers in the way the July 2012 sequence was. The honest framing is that the compound interaction this week is statistically much more likely to produce a G1 or G2 arrival than anything more dramatic. The probability of a G3 is small but non-trivial. The probability of anything higher than that is very small. What the July 2012 case illustrates, however, is that compound CME forecasting is hard. The merger physics is poorly constrained by available real-time observations. The Space Weather Prediction Center's operational modelling tools, including the NLIL model and its more recent successors like the Euphoria model, can simulate compound interactions but require initial conditions that are not always fully specified by the available coronagraph imagery. The forecasting community has invested considerable effort over the past decade in improving compound CME prediction, particularly in the wake of the May 2024 G5 event and the October 2024 G5 event, both of which involved compound interactions that were initially under-forecast in the published headline products and were updated upward as the modelling caught up to the operational timeline. The pattern that has emerged from the post-event analyses of those recent events is that the initial published forecasts tend to err on the side of conservatism. The published KP at first issuance is typically lower than the eventual arrival KP when the event involves a compound merger that was not fully modelled at issuance. The forecasts get updated, the alerts come out, the Aurora forecasts get revised, but the initial public-facing number tends to be lower than the eventual outcome. This is not a flaw in the system. It is a structural reality of operational forecasting under uncertainty. The system errs on the side of not overwarning, with the understanding that updates will be issued as the modelling completes. For this week, the operational read is that the published KP 3.67 is the conservative initial estimate, that the modelling will update within 24 to 48 hours, and that the updated forecast may come in at the same level or may come in higher. If it comes in higher, it will not come in dramatically higher, because the individual eruptions this morning are not extreme outliers, and because the compound interaction with the June 2nd filament is constrained by the relatively modest velocity of the filament-driven structure. The probability mass for the eventual arrival is, in my read, concentrated between KP3 and KP6, which spans the range from quiet through G2 moderate storm conditions. Anything higher than KP6 is possible but unlikely. Anything lower than KP3 would require the Earth-directed components to be significantly weaker than the current stereo A triangulation suggests, which is also possible but unlikely. The honest framing remains that we do not know. The honest framing remains that the modelling is in progress. The honest framing remains that the next 72 hours are the answer. We will not know until the modelling completes. We do not know now. The honest framing again is that the published forecast is provisional, the modelling is in progress, and the next 72 hours are the answer. Part 6. The Backup Satellite. There is one more operational detail from the published documents that the audience should know about, because it is the kind of detail that, if you do not know it, can fuel a cover-up framing that this channel exists to push back against. The Space Weather Prediction Center alert that announced the X1 flare this morning contained the following parenthetical comment, quote, "GOES 18 outage, so using GOES 19, end quote. That comment, in operational terms, means the primary GOES East satellite that NOAA uses for X-ray flux monitoring is currently offline. Today's X1 flare, which was the largest space weather event of the past 24 hours, was characterized using GOES 19 as a backup. The measurement is real. The data is well calibrated. The X1 classification is supported by multiple, independent observational chains, including the Type 4 radio sweep, the 10.7 cm radio burst, and the optical observations from ground-based H-alpha telescopes. There is no measurement gap. There is no characterization uncertainty. The flare was an X1 with high confidence, and the entire space weather infrastructure agrees on that classification. But the sensor redundancy is part of the story, because it is connected to something we talked about in yesterday's video on the 4-day fireball cluster. Yesterday we explained how the GOES 19 geostationary lightning mapper, an instrument that was originally designed to detect lightning flashes in Earth's atmosphere, was the instrument that confirmed the Cape Cod bolide attribution on May 30th. The same instrument, on the same spacecraft, is now also being used as the backup X-ray monitor for the largest space weather event of the week. GOES 19 is, in a real sense, doing the work of two spacecraft this week. It is the instrument that closed the Cape Cod case in 48 hours, and it is the instrument that is currently characterizing the X-ray emissions from Region 4, 455, while the primary spacecraft is down. The honest framing here, again, is that the system is operating as designed. NOAA's GOES-R series, which includes GOES 18 and GOES 19 as a constellation pair, was built with redundancy as a core design principle. Either spacecraft can take over the primary observational role for the other if one of them goes offline. The instrument suites are essentially identical. The data quality is essentially the same. There is no operational degradation in space weather coverage during a GOES 18 outage. The data on which today's X1 classification is based, the data on which the M9.3 and M7.7 CME triangulations are based, the data on which the proton flux measurements are based, the data on which the radio burst characterizations are based, is full quality data from GOES 19. What the outage does mean, in a structural sense, is that the federal space weather monitoring infrastructure is currently relying on one spacecraft instead of two for X-ray observations, with the second spacecraft, GOES 18, currently offline for reasons that NOAA has not publicly elaborated on at the time this video was produced. Outages happen, spacecraft instruments require maintenance, solar panels degrade, pointing systems fail, software needs to be updated. None of those things are cover-ups. All of them are part of the routine reality of operating a fleet of geostationary observation satellites for 2 decades. But it is worth noting, because the audience deserves to know, that the most important space weather measurements of this week are being made via a backup. And it is worth noting that GOES-19, the backup, has been doing remarkable double duty this week. It found the Cape Cod bolide. It is now monitoring the X-ray output of Region 4455. The same spacecraft, the same instrument suite, is connecting yesterday's documentary about the Fireball cluster to today's documentary about the solar flares. Not causally, structurally. The federal detection chain, the same chain we talked about yesterday, is the chain that is also handling today's story. The detection chain is the through line. That is what the discussion text is telling us. That is what the X1 alert parenthetical is telling us. They are telling us. The full picture is in the public record. The infrastructure is operating as designed. The story this week is the same story it was yesterday, and the week before, and the month before. We have built an observation system dense enough to catch most of what the universe routinely does in real time, with redundancy designed into the architecture. When part of the system goes down, the other part takes over. When the slow filament from yesterday meets the faster eruptions from today, the combined system models the merger. When the modelling cannot keep up with the operational timeline, the discussion text says so explicitly. The transparency is there, the honesty is there, the infrastructure is there. The only thing that is not there, in mainstream coverage of any of this, is the depth. The headlines do not get past KP 3.67. The headlines do not mention modelling still ongoing. The headlines do not mention the compound CME setup. The headlines do not mention that GOES-18 is offline and GOES-19 is doing the work of 2 spacecraft. That is what we are here for. Now let me bring you back to the visible disk, because there is something else happening up there that the morning forecast does not capture in the headline, but that the discussion text mentions in passing. Region 4455 is not the only sunspot that is loaded up right now. There are 4 others. Part 7. The other 4. The Space Weather Prediction Center, in its morning discussion of June 3rd, identifies 8 numbered active regions on the visible solar disk. We have spent most of this video talking about one of them, Region 4455, because it produced 3 major flares in 10 hours, and because it is the source of the 2 confirmed Earth-directed CMEs that are on their way to us. But the discussion text also calls attention to 4 others that have done something quietly significant in the past 24 hours. They have developed gamma magnetic configurations. A gamma magnetic configuration, in the Mount Wilson classification scheme that solar physicists use to describe sunspot magnetic complexity, is a sunspot region in which positive and negative magnetic polarities exist in close proximity without a clear separation. The boundary between the 2 polarities is not a simple line, but a complex shape, with positive and negative regions interleaving. The next step up from gamma is delta, which is the most complex classification, where positive and negative polarities share a single penumbra. Delta regions are the most flare-productive of any classification. Gamma regions are the precondition. They are the configurations that, with additional flux emergence, can develop into deltas. 5 regions on the visible disk are currently classified as gamma or beta gamma. Region 4455, which we have been talking about, is one of them. The other 4 are Region 4458 at heliographic position South 5 West 8, Region 4459 at North 14 East 35, Region 4460 at South 22 West 74, and Region 4461 at South 20 East 57. A 6th region, Region 4462 at North 17 East 59, is classified beta but is in early development and could escalate. All 4 of the additional gamma regions are described in the discussion text as having shown very rapid flux emergence during the reporting period. That is the operational language that means the region is actively growing, with new magnetic flux pushing up through the photosphere, with the magnetic complexity increasing as the flux emerges. Each of those regions has its own assigned flare probabilities. Region 4458 has a 50% C-flare probability, a 10% M-flare probability, and a 1% X-flare probability. Region 4459 has the same numbers, Region 4460 has a 25% C-flare probability and a 5% M-flare probability. Region 4461 has a 45% C-flare probability and a 10% M-flare probability. Region 4462 has a 15% C-flare probability. Those probabilities, on their own, are not enormous. None of them individually approach the productivity of Region 4455 at its 40% M-flare probability and 10% X-flare probability. But you do not have to add them all up to see what the picture looks like. The Space Weather Prediction Center's forecast for the next 72 hours in the discussion text summarizes the disk this way. Quote, solar activity is expected to be at moderate levels through 5 June with M-class radio R1 to R2 minor to moderate flaring likely and a slight chance for X-class radio R3 strong or greater primarily due to regions 4455, 4458, 4461 and 4462. End quote. 4 regions are named as potential M-class and X-class producers for the next 72 hours. Region 4455 is not alone. Even if Region 4455 quiets down after this morning's triple sequence, even if it spends the rest of the week relaxing toward a stable post-flare configuration, the other 3 named regions could still produce significant flares. And importantly, if the other 3 named regions produce CMEs while the inbound stack from Region 4455 is still en route to Earth, the operational picture could become more complicated, not less. What does that mean practically? It means that the next 24 to 48 hours are not a closed forecast window. The published KP 3.67 projection is based on a snapshot of the disk at 12:30 UTC this morning, with the M9.3 CME already gone, the M7.7 CME already gone, the X1 inbound to the coronagraph, and the 4 additional gamma regions not yet having produced anything significant. If any of the 4 additional regions produces an M-class flare in the next day, the published forecast will need to update. If any of them produces an X-class flare in the next day, the published forecast will definitely need to update. The probability of each of those things, on a region-by-region basis, is modest. But the probability that none of them happens, across 4 regions with active flux emergence and gamma configurations, is not high either. This is what a loaded disk looks like. This is what the operational forecasters are looking at when they write modelling is still ongoing. They are not just waiting on the existing CMEs to be modelled, they are also watching the rest of the disk for additional eruptions. They are watching, in particular, the regions that have moved into gamma configuration in the past day, because the trajectory from beta to gamma to delta is the trajectory that produces the largest events. There is one more piece of disk context worth mentioning. The discussion text notes that region 4449, which is at South 8 West 72, has decayed to plage, which means the spot complex has dissolved and only the surrounding bright magnetic facular emission is left. 3 other regions, 4450 through 4453, are similarly in late-stage decay or are minor unspotted complexes. Those regions are not flare candidates. The active disk, the part of the disk that is currently producing significant activity, is concentrated in the regions we have just walked through. The visible disk is dynamic in both directions. Some regions are decaying, some are emerging. The net balance at the moment favours emergence, with 5 regions actively gamma classified or beta gamma classified, and 4 explicitly named as potential M-class and X-class producers. Let me give you the geographic picture of the disk as it sits this morning, because it helps to visualise where the loaded regions are relative to Earth's view of the Sun and to each other. Imagine the visible solar disk as a circle, with our line of sight going through the centre. North is up, south is down, west is to the right in the direction of solar rotation, east is to the left. Region 4455 is at north 14 west 16, which puts it roughly in the upper right portion of the disk, fairly close to the central meridian. That position is the most geo-effective position for Earth-directed CMEs because eruptions from regions near the central meridian propagate more directly along the Sun-Earth line. Anything region 4455 does in the next day or two, while it sits near the central meridian, has a high probability of being at least partly Earth-directed. Region 4458 is at south 5 west 8, very close to the central meridian on the southern side. It is the second most geo-effective position on the disk. Region 4459 is at north 14 east 35, which puts it about a third of the way from the central meridian toward the eastern limb. As the Sun rotates over the next few days, 4459 will move toward the central meridian, becoming more geo-effective as it rotates. Region 4461 is at south 20s 57, further out on the eastern side. It will not become highly geo-effective until later in the week, but it is moving in the right direction. Region 4460 is at south 22 west 74, well out on the western limb, becoming less geo-effective each day as it rotates off the disk. Region 4462 is at north 17 east 59, on the eastern side similar to 4461 in geo-effective trajectory. What this geometric picture tells you is that the disk's loaded regions are distributed across multiple longitudes, with several of them currently in or moving toward the most geo-effective positions. If you imagine the disk as a clock face from Earth's perspective, the most dangerous time for an erupted CME to be aimed at us is when its source region is somewhere around 12 o'clock to 2 o'clock on the disk face, which is roughly north latitudes with western or central longitudes. Region 4455 is right in that danger zone. Region 4459 is approaching it. Region 4462 will approach it over the next several days. The disk is loaded, and the loaded regions are mostly in or moving toward Earth-effective longitudes. There is one more piece of magnetic disk context worth understanding. The Carrington maps that solar physicists use to track magnetic flux distribution on the full solar surface, integrated across multiple solar rotations, currently show enhanced positive polarity flux in the northern hemisphere and enhanced negative polarity flux in the southern hemisphere, which is consistent with the dominant Hale orientation for solar cycle 25. The anti-Hale regions, like region 4455, are emerging into this background field with their leading polarities reversed. The shear that we have been discussing throughout this video is, in part, the shear that arises from the mismatch between the anti-Hale region's own polarity tilt and the prevailing background field that surrounds it. That mismatch is not local. It is the polarity of the entire hemispheric magnetic field that the anti-Hale region has to accommodate. The amount of magnetic energy that can be stored in an anti-Hale configuration depends on how much shear can accumulate before the configuration becomes unstable, and the answer depends in part on the strength and the direction of the surrounding field. In a typical week of solar cycle 25, this kind of loading would itself be the lead story. The disk being this loaded, with this many regions in late flux emergence phase, with multiple anti-Hale exceptions in active flaring, with the gamma classification population this dense, is a significant operational picture. In any other week, this would be the story. This week, it is a side note, because the lead story is the triple sequence that has already happened and the CMEs that are already inbound. But it is a side note that you should hold in your head, because it tells you what the rest of the week could look like if region 4455 is not done. The honest summary of where we are 3 days into this video's worth of context is this. The Sun has fired 3 times this morning from a wrong-way sunspot. 2 of those eruptions are confirmed Earth-directed. A third is inbound. A slow filament from yesterday is going to interact with the faster eruptions behind it. The published forecast made before the modelling completed is provisional. The disk is loaded with 4 other potential producers. The X-ray monitoring is being done on the backup spacecraft because the primary is offline. The next 72 hours will give us the answer about the inbound stack, and the next 72 hours could also give us additional events from the regions that have not yet erupted but are loaded. This is the most active operational picture for the visible disk in this solar cycle's declining phase. We are not at solar maximum anymore. The peak of solar cycle 25 was reached in October of 2024. We are now in the declining phase, which historically can still produce significant events, but at lower average frequency than peak years. The events of this week are not the peak. They are events from the declining phase that, when they happen, can still produce week-defining stories. And that brings us to one more piece of the picture, the rest of the week. Because while the Sun has been doing what we have just walked through, Earth has not been quiet either. Let me give you a brief sweep of everything else that has happened in the past 24 hours, because the sky is busy in more than one direction. Part 8. Everything else. This week. This week has produced more news, across more domains, than any one documentary can give the full treatment. Let me sketch what we're not going into in detail today, because the lead story has earned its primary slot, but because the rest of the picture is relevant context for what the audience is watching. First, earlier this morning, in the hours that overlapped with the second and third flares of Region 4455, the Mendocino Triple Junction off the coast of Northern California produced a sequence of 3 earthquakes within 2.5 hours. The first was a magnitude 5.7 at 10:53 Universal Time, located 154 kilometers west-southwest of Pistol River, Oregon, at a depth of 10 kilometers. The second was a magnitude 5.08 at 12:45 Universal Time, located 64 kilometers west of Petrolia, California, at a depth of essentially zero, less than half a kilometer below the surface. The third was a magnitude 4.47 at 13:11 Universal Time, located 65 kilometers west of Petrolia, at a similarly shallow depth. The National Oceanic and Atmospheric Administration issued a tsunami message for the magnitude 5.08 event. The message was an informational one, not a warning, but it was issued, and the issuance is in the federal catalogue. The Mendocino Triple Junction is the most seismically active part of California because it is the point where 3 tectonic plates meet. The Pacific Plate, the North American Plate, and the Juan de Fuca Plate, or more specifically its southern fragment, the Gorda Plate, converge there. The earthquakes today were on or near the southern edge of the Cascadia subduction zone, which is the megathrust system that runs from Northern California up through Oregon, Washington, and southern British Columbia. Cascadia has not produced its full margin rupture event since January 26, 1700, when a magnitude approximately 9 event triggered a tsunami that crossed the Pacific and was recorded in Japanese harbours. Earthquakes on the southern edge of Cascadia, in the magnitude 5 to 6 range, are not unusual on multi-decade timescales. The cluster of 3 in 2.5 hours is more unusual, but still within the variability of the regional seismicity. The earthquakes are not connected to the solar flares. There is no causal link between solar activity and earthquake nucleation at the energy scales we are talking about. Solar flares release 10 to the 25 joules. The earthquake energy release for a magnitude 5.7 is on the order of 10 to the 13 joules. The two phenomena differ by 12 orders of magnitude in energy and proceed from entirely separate physical mechanisms. The temporal coincidence, like the temporal coincidence with the fireball cluster, is just that, a coincidence. Second, Typhoon Jangmi is currently active in the western Pacific, threatening southern Japan with torrential rain. NASA Earth Observatory published a feature on the storm this morning. The western Pacific tropical season typically peaks in August through October, so an early season typhoon in early June, large enough to be feature coverage at NASA Earth Observatory, is on the unusual side. In parallel, the eastern Pacific has produced Tropical Depression 1E, the first numbered eastern Pacific storm of the 2026 season, located well southwest of the southern tip of the Baja California Peninsula. The Atlantic Basin is quiet, with no tropical cyclone formation expected by the National Hurricane Center over the next 7 days. The contrast between the active Pacific basins and the quiet Atlantic is worth tracking through hurricane season, particularly given the warming El Niño signal that the Climate Prediction Center has documented through the past several months, with the Oceanic Niño Index moving from negative 0.55 at the end of 2025 to positive 0.11 in the February-March-April 2026 season, a trajectory the Climate Prediction Center characterizes as warming. Third, NASA officially ended the MAVEN mission this week. The Mars Atmosphere and Volatile Evolution spacecraft, which had been in orbit at Mars for more than 11 years, was the first dedicated mission to study how Mars lost its atmosphere. The answer that MAVEN delivered, over the course of its operational life, is that the solar wind stripped Mars of its atmosphere over approximately 4 billion years after the Martian magnetic dynamo shut down, and the planet lost the magnetic shield that would have protected its atmospheric reservoir from the relentless ablation of solar wind plasma. The ending of MAVEN is, in a small way, a bookend. The mission that documented how the Sun ate the atmosphere of one terrestrial planet ended in the same week that the Sun's magnetic field is testing the magnetic shield that has protected this terrestrial planet for as long as life has existed on it. We are not Mars. Our magnetic field is intact. The CMEs that are inbound are not in any meaningful physical sense threatening to strip Earth's atmosphere. But the MAVEN story is a reminder, in the background of this week's solar activity, of what the Sun is capable of when the planet on the receiving end lacks the protection that we have. The poetic resonance is real, even though the physical consequence for us is not. Fourth, the Omega Block weather configuration that has dominated the continental United States since late May, the same configuration we walked through in the videos a few days ago on the coastal cyclone and the continental flood forecast and the bi-coastal heat dome, is continuing this week. The mid-Atlantic and northeast are heading into a Friday and Saturday with mid to upper 80s through low 90s, with some locations approaching 95. The Weather Prediction Center has flagged moderate to major heat risk, level 2 to 3 of 4, across portions of the mid-Atlantic for Friday and Saturday night. The atmospheric backdrop the audience is currently living under, the heat dome that yesterday's Fireball Cluster documentary referenced as the continuing Omega Block manifestation, is the same backdrop. The sky is busy, the atmosphere is busy, the sun is busy. We are watching all of it at once, in continental scope, in real time. Fifth, the launches. 10 orbital launches are scheduled across the next 7 days. SpaceX Falcon 9 launches from Vandenberg from Cape Canaveral. Chinese launches from Taiyuan, from Wenchang, from Haiyang. A South Korean solid fuel demo flight from a sea launch platform. A Japanese H330 test flight from Tanegashima. The orbital industry continues at its current pace, with the next several days bringing Starlink missions, unknown Chinese payloads, and the H3 test flight. Blue Origin, per a statement from CEO Dave Limp earlier this week, has committed to resuming New Glenn flights by year's end after the New Glenn pad explosion at the Cape last week. The space industry is, in a routine way, doing what it does. The launches are not coordinated with the solar activity. They will fly regardless of KP, with the standard mission rules that govern radiation exposure for crewed missions and orbital safety for uncrewed ones. All of this is happening at once. The Mendocino quakes, the 2 Pacific basins firing up, the Maven mission ending, the heat dome continuing, the launches scheduled. And, in the middle of it all, the 3 solar flares this morning, with 2 confirmed Earth-directed CMEs, a 3rd inbound, the compound interaction setup, the 4 other gamma configuration regions on the disk, the GOES-18 outage, the modelling still ongoing language. The sky is busy. The Earth is busy. The audience that has been watching since the Cape Cod bolide on May 30th has been getting more dramatic events per day than is typical for any given week. Some of that is real. The Mendocino quakes are real. The triple flare sequence is real. The Fireball cluster was real. Some of it is the heavily instrumented era making routine activity fully visible to a continental audience for the first time in human history. The sun has fired 3 times this morning. 2 confirmed Earth-directed CMEs are on their way. The forecast is provisional. The next 72 hours are the answer. Everything else, all the other items in the sweep we just walked through, is the wider context the audience is living inside. The lead story is 1 story. The wider context is a dozen. Let me bring this home. Part 9. What is happening above us? I want to land this video by telling you what I actually think is happening this week, and what I think the right way to interpret it is, and what I think you should do with the next 72 hours of operational uncertainty about what the inbound CMEs will actually produce. What is happening this week is this. The universe is doing its routine work. Region 4455 is an anti-hail exception, statistically rare but well understood, productive in major flares in a way the statistical literature predicts. The Fireball cluster of the past 4 days was a high end of normal Poisson cluster, statistically rare but well understood, expected to occur somewhere in the US catalogue roughly once every 25 to 40 years, under the null hypothesis of independent arrivals. The Mendocino quakes are a normal expression of plate tectonics at a triple junction. The Omega Block is a Rossby wave amplification pattern that has shown up multiple times in our recent coverage. The Pacific tropics are firing up early because the warming El Niño signal is loading the basins. Maven ended on schedule after 11 years of productive science. The launches are continuing on the cadence of a commercial and state launch industry that has been increasing in tempo for years. None of these things are anomalies. All of them are the kinds of events that the underlying physical systems produce, sometimes in concentrated clusters, sometimes in extended quiet stretches. This week, several of them happen to concentrate. The concentration is statistically unusual. The events themselves are not. What is not routine is our ability to watch all of it happen at once. The Cape Cod bolide was confirmed in 48 hours by a satellite that was originally designed to find lightning. The Midwest Fireball was captured by a consumer dashcam in Wadsworth, Ohio. The Maine Green Fireball was caught on a Seebeck Lake livestream that exists because someone somewhere decided to leave a camera pointed at a lake for some other purpose, and the bolide just happened to enter the frame. The M9.3 flare was characterized in real time by GOES 19 because GOES 18 is offline. The M7.7 CME was triangulated against stereo A imagery from a position tens of millions of kilometers from Earth. The Mendocino tsunami message was automated and issued within minutes of the magnitude estimation. The Omega block has been characterized in detail by area forecast discussions from at least 8 National Weather Service offices across the country. The heat dome is being watched by hundreds of personal weather stations and a network of professional surface observation stations and satellite-based remote sensing platforms and ensemble model runs from at least 4 independent forecasting agencies in at least 3 countries. We are watching the universe with more instruments than anyone in human history. The events that have always been happening, that have always been part of how the solar system operates, are now visible to us in continental scope, in real time, with multiple independent observational chains converging on the same physical phenomena. That is the new thing. The events are not new. The visibility is new. And the visibility is what creates the audience experience of unusual concentration, because the universe has always concentrated activity sometimes. But until our era, almost none of that concentrated activity reached the public except as filtered headlines from media organizations that did not have the depth of access to the operational data that you sitting at home today can have if you know which documents to read. That is what we have been trying to do for the past hour and a half. We have been reading the documents together, the 3-day forecast, the forecast discussion, the X1 alert with its parenthetical comment about GOES 18 being offline, the SDO imagery of region 4455 with its anti-hail configuration, the CNEOS catalogue of fireball energies, the Mendocino magnitude reports, the NASA Earth Observatory feature on Typhoon Jangmi. All of these documents are public. All of them are accessible. Most of them are read by almost no one outside of the operational forecasting community. And the gap between what the documents actually contain and what the headlines actually report is the gap this channel exists to close. The right way to interpret this week, in my view, is the way the documents themselves suggest. The sun has done something that anti-hail physics predicts it can do. 2 confirmed Earth-directed CMEs are on their way. The modelling is in progress. The forecast is provisional. The next 72 hours will tell us whether the published KP 3.67 holds, or whether the compound interaction with yesterday's filament pushes the KP higher. If it pushes higher, the alert chain will update. The space weather community will issue new products. The aurora forecasts will update. The grid operators will receive new advisories. The satellite operators will adjust their attitude control margins. The polar aviation routes will get new high-frequency communication guidance. The system that has been built to handle exactly this kind of operational uncertainty will operate as designed. If the KP holds at 3.67, the system will also operate as designed. The forecast will have been right. The compound interaction will have produced a glancing arrival that does not push the geomagnetic environment into storm territory. The next 72 hours will be quiet. The next several days will see region 4455 rotating further westward toward the limb, where its magnetic configuration will become less and less geo-effective for any subsequent eruptions. The week's solar story will close with 2 confirmed Earth-directed CMEs that arrived as light disturbances rather than as auroral spectacle. We do not know which of those 2 outcomes is going to happen. Nobody knows. Not me. Not the Space Weather Prediction Center. Not the operational forecasters who wrote the discussion text this morning. The modelling is still ongoing. The honest framing is that this is the question of the next 48 hours, and the question will be answered by the imagery as it comes in from the coronagraphs, by the in-situ measurements as the CMEs cross the orbit of the ACE and DSCOVR spacecraft at the L1 Lagrange point, by the magnetometer data from Earth's surface as the leading edge of the merged structure arrives in geomagnetic range. What I want you to take away from this video more than anything else is this. You have spent 4 days watching the sky over America for fireballs. Now you are being asked to watch the sky over America for whatever the inbound CMEs produce. Both vigils are reasonable. Both are responding to genuinely unusual events, statistically unusual but physically well understood, that have happened to concentrate in the same calendar week. Both events have given you the experience of looking up, of paying attention, of asking what is happening above us. The answer, in physical terms, is that the solar system is doing its routine work, and you are watching it with more clarity than any previous generation had access to. The answer, in audience terms, is that pattern recognition is a powerful instinct, and it deserves to be honoured by walking the patterns through the physics until they resolve. The pattern, when you walk it through the physics, resolves into two independent stories. The fireball story is the story of how routine atmospheric meteoroid entries become visible to a continental audience through a dense network of consumer cameras and federal satellite instruments. The solar story is the story of how routine anti-hail active region productivity becomes visible to a continental audience through public NOAA documents and triangulated CME imagery. The temporal coincidence is real. The causal connection is not. The wonder is real. The fear is not warranted. The honest framing is the framing the documents themselves provide, if you read them all the way through. I want to add one more thought before we close, because I have been thinking about it the whole time we've been recording. The audience that watches a documentary like this one is doing something that almost nobody in human history has been able to do. You're sitting at home, in your kitchen, or your living room, or your office, with a device that can pull up the actual public discussion text of the operational space weather forecast that NOAA has just issued. You can read the same document that the grid operators are reading, that the polar aviation routing teams are reading, that the satellite operators are reading. You can pull up the same LASCO C2 coronagraph imagery that the forecasters are using. You can look at the same SDO magnetogram of region 4455 that the operational analysts at SWPC are looking at. The infrastructure that we have built as a civilization to monitor the sun in real time, and to monitor Earth's atmosphere in real time, and to monitor the seismicity of the entire crust in real time, is an infrastructure that you have at-will access to from your phone. That access is barely 30 years old. Before the World Wide Web went public in the early 1990s, none of this was reachable. The forecast existed, but it was distributed by fax to government agencies and to a small list of operational customers. The imagery existed, but it was stored on tape archives in Boulder, Colorado, and at Goddard Space Flight Center and at JPL, available only to researchers who knew which curator to email. The discussion text existed, but it was an internal product. None of it reached you, not because the agencies were hiding it, but because the distribution architecture did not exist yet. We are the first generation to be able to watch the universe do its routine work in real time, at the level of operational detail. That is a new thing in human experience. It is the new thing this week has been showing you. The bolides have always entered the atmosphere. The solar flares have always erupted. The earthquakes have always shaken the crust. The typhoons have always formed early in El Niño years. The Maven-style missions have always ended at the end of their useful lives. Everything that has happened this week is the kind of thing that has been happening throughout Earth's history, throughout the entire history of the solar system. The only thing that is new is our ability to be present with it, to read the documents that describe it, to see the imagery that captures it, to know the names of the sunspots that produce it. That is, in my view, the actual story of this week. Not the fireballs, not the flares, not the quakes, not the typhoons. The story is that we are watching, with depth, with detail, with the documents in our hands, while the universe does what it has always done. The story is the audience. The story is you, paying attention, reading along, asking the right questions, watching the sky for what comes next. There is one piece of this video that I want to leave you with as the open loop. We have spent 90 minutes walking through what has happened, what we know, what the documents say, and what they imply. What we have not done, because we cannot do it yet, is tell you what actually arrived. The CMEs are still en route. They will reach the L1 Lagrange point in the next 24 to 48 hours, give or take. They will be measured directly by the ACE and Discover spacecraft before they reach Earth's magnetosphere. The southward BZ component of the merged structure will be measured. The arrival time at Earth's magnetic field will be pinned down. The geomagnetic response will begin within hours of the structure crossing the magnetosheath. We will know, by Friday at the latest, what the inbound stack actually produced. If you watch the sky on Friday night, and you happen to be in the northern tier of states, you may see something. You may see auroras visible from latitudes that do not usually get them. You may see, in the same sky that gave you 5 fireballs over 4 days, the slow, undulating green and red of a geomagnetic storm. You may see the sun's reply to 4 days of looking up. Or you may see a quiet sky, which would also be a kind of reply, the kind that says the published forecast held, and the compound interaction did not amplify the way it sometimes does. Either way, the sky will tell you. The sky has been telling you all week. It has told you with bolides over Cape Cod, with fireballs over the Great Lakes, with green flame over Maine, with 3 solar flares from a wrong-way sunspot, with quakes off the coast of California, with a tsunami message that came and went. It has been telling you what the universe routinely does, with more instruments than any audience has ever had to read the messages. I will see you again tomorrow. Whatever the sky has to say next, we will read the documents together. We will walk through the physics. We will be honest about what we know and what we do not. We will land you in the time it takes a documentary to land on the right answer about what is actually happening above us. Before I close, one final note. If you do see auroras tonight or tomorrow night or Friday night, take a moment with them. Most people in the lower 48 have never seen auroras in person, and the chance to witness one without having to travel to Alaska or Iceland or northern Scandinavia is the kind of opportunity that comes around only a handful of times in a typical lifetime. The G1 and G2 geomagnetic events that may come out of this week's compound CME arrival could give that experience to people in states that almost never get it, in towns that have never produced an aurora photo before in their local archives. Northern Maine, northern Minnesota, the Upper Peninsula of Michigan, northern Washington State, northern North Dakota. If you live in one of those areas, watch the northern horizon after sunset. Use a phone camera if you have one, because modern phone cameras pick up aurora colours better than the naked eye does. Take a photo, send it to someone. Be present with what the sun has sent you. That experience when it happens is the audience-facing payoff for a week of paying attention. It is the visible answer to the question that this video has been asking. The sky is busy. The audience is paying attention. The documents are public. And the next 72 hours are still being written.